environmental challenges, especially ocean acidification and pollution. Greenhouse gas emissions are increasing the acidity of our oceans and corroding fragile marine life. To better understand and measure these impacts, scientists are using the calcium-45 radioactive tracer technique. They set up experimental aquaria with seawater at different pH levels and add calcium-45 as a tracer to measure the difference in the growth of corals and shellfish. Gathering this data is vital to protecting the health of coral reefs, which are so critical to marine ecosystems and coastal communities. Today, people are facing dangerous levels of contaminants in their seafood, from heavy metals, pesticides, microplastics, and more. Using techniques based on mass spectrometry, scientists are able to identify the level and source of pollutants in seafood. When analyzing a sample, they remove all its organic matter, leaving only the contaminants behind, and then use specialized analytical instruments to determine contaminants present in the sample. Having this data helps coastal countries make appropriate management decisions to regulate pollution. These nuclear and nuclear-derived techniques provide a unique window into understanding the processes behind ocean change, an understanding that can help us secure a healthy ocean for the future. The IAEA, through its marine environmental laboratories and its technical cooperation program, supports member states in acquiring and efficiently using these nuclear techniques. Gathering this data is vital to protecting the health of coral reefs, which are so critical to marine ecosystems and coastal communities. Today, people are facing dangerous levels of contaminants in their seafood, from heavy metals, pesticides, microplastics, and more. Using techniques based on mass spectrometry, scientists are able to identify the level and source of pollutants in seafood. When analyzing a sample, they remove all its organic matter, leaving only the contaminants behind, and then use specialized analytical instruments to determine contaminants present in the sample. Having this data helps coastal countries make appropriate management decisions to regulate pollution. These nuclear and nuclear-derived techniques provide a unique window into understanding the processes behind ocean change, an understanding that can help us secure a healthy ocean for the future. The IAEA, through its marine environmental laboratories and its technical cooperation program, supports member states in acquiring and efficiently using these nuclear techniques.
Okay, should we start? So let's start with the part two of our event here at the COP26. I would like to welcome all of you again, and for those also who have just joined us for this part of the event. We are at the COP26 talking about climate change adaptation, climate science, and ocean change. And in particular, the role that nuclear techniques and nuclear technologies can play in this context. We just concluded the part one, where we have heard a lot about how climate science and nuclear science is connected. And we had focused on climate smart agriculture. Now, in this part of our event, in the second part, we will look into the connection between ocean change and climate change, and how nuclear applications, nuclear techniques, nuclear science can make a difference. The IAEA, and many across the world don't know this, has its own environmental laboratories, which are in Monaco. In these labs, the scientists, they gain knowledge and insights on how the ocean is changing. We are talking here about changes that are related to the marine pollution, to habitat destruction, to biodiversity loss, to plastic pollution, to ocean acidification, and so on and so forth. So some of those scientists who work in the environmental laboratories in Monaco are now here with me in this event and have joined me virtually. And they will highlight the role that the agency is playing in this important scientific effort. And they will better explain now the issues that we are facing when it comes to ocean change and climate change. With that, let me turn to my first expert, Dr. Marc Metian. He is a researcher at the moment at the environmental laboratories of the International Atomic Energy Agency in Monaco. So Marc, I would like to welcome you to this event at COP26. Thank you for being available to talk to us about ocean change, and in particular ocean acidification. Can I ask you, Marc, could you briefly tell us about what actually is that connection between climate change and the ocean or the oceanic system?
Of course, Martin, thanks for inviting me. So, yeah, it's really simple. Oceans is playing a huge role on climate in general on Earth. As you may know, it covers 70% of the surface. Ocean regulate global climate in general, mediate temperature, drive the weather. So it's something that we cannot deny. And now, with the increase of carbon emission, like burning for fossil fuels and so on, and the climate change that we're talking about, the ocean are changing. So this is what make the big connection. So the huge role of the ocean in general, and now the connection with the carbon, the reaction with climate change.
So you are saying the oceans are changing. Now, in what way are they changing, and what is the impact of that, what we call the ocean change on all of us?
Basically, I mean, the list is very long. But among the ocean changes, because they are plural, expected, already observed, I would say that more extreme weather events, changing ocean currents, rising sea level rise, rising temperature, melting sea ice and sea ice, but also the chemistry by itself is changing. So we can attend now already an increase of hypoxic weather. So when the oxygen into the water is reducing, and ocean acidification, as you mentioned. And this is key because the problem is livelihoods and humans in general are really depending on oceans for numerous key goods and service. And they are general under threats with this climate change, and thus reaction the ocean changes.
Right. With that, Marc, you have already anticipated my next question, and that is, why should we care about ocean acidification? It sounds like something that scientists should care about, but what impact does it have, or could it have, if it accelerates with climate change. What impact could it have on all of us? Why should we care about this?
As I said, basically for the specific case of ocean acidification, where the water become more acidic and there's a different reaction occurring in the water, basically the risk is that some of the organism will have some troubles. So the biodiversity could be impacted. And among those, I mean, we know that since the ocean acidification will deeply impact calcifying organisms. The organisms that are building this shell or the corals, when you know the corals, there's this skeleton. And basically, the ocean change and the ocean acidification will directly impact those organisms. And this is why it's so important, because a lot of people in the world and the global population are depending on this for the goods and service. For example, seafood, for example, as a food, for example, as tourism for when we talk about corals affected by ocean acidification, then you have this coral reef that will be impacted. So protection of the coast and so on, and tourism for divers and so on. So it's a lot of impact that we expect. And already in US, a few years ago, there was a big impact on aquaculture production of oysters, for example. So we saw it, and it will be worse in the past. So that's why it's so important.
Right. So, Mark, you are working in Monaco in the laboratories of the IAEA. So what kind of research and work do you do in this space, and how is that relevant, the work that you do there, in the context of this discussion of ocean change and climate change?
Basically, the IAEA is working hard on to assess the impact of ocean acidification using nuclear techniques. So basically, we are using different tracers. I'll not go into details, but tracer, for example, of calcium, because as I said, the calcifying organism will be impacted. So we want to know at which rate, what will be the quantify this impact on different organisms that are commercially important or that are important in terms of biodiversity. So we play with our tools, the radio tracer, to try to assess what's the impact. The same way also we'll try with other techniques to try to understand how the organism, the health of the organism are impacted too. So we'll use the way they eat, the way they swim, all these impacted will use other tools, the audio radio tracers. And in addition, of course, we are pushing for the use of this technique for other aspects. For example, we know now with some use of isotopes, we are able to track and to record the past history of ocean acidification. So we know now that we are really in a condition that really is different than the past and not so good for the organism right now. And of course, when we talk about the action of the IAEA, we try to help as much as possible the member state to report, for example, the ocean acidification in the ocean, and also transfer our knowledge and on the know-how about these techniques to assess the impact. And now, to finalize on this, it's also important to know that in front of the science that will push is basically also to try to find a solution. So there's in the sphere of scientists right now, they are mentioning some alkalinization process, and that's what we'll go for. Try to see if the different hypotheses or different solutions that are offered by scientists are viable. And so in our laboratory, we are trying to test that with our techniques, of course.
Right. Mark, my last question to you. The knowledge that you are generating in the laboratories that you have been describing on ocean acidification, on the connection between ocean change and climate change, how does that knowledge actually get out of the lab? You know, we don't want that knowledge to stay within the lab. We want that knowledge to get out of the lab. We want countries, member states, developing countries to benefit from that knowledge so that they can use it in their own adaptation strategies. How is it being done?
Basically, there's the different ways, but the most important one is when we work hands in hands of our colleagues from technical cooperation projects. So nationally, regionally, or between region, we are providing expertise. We are helping to build some capacities to train people with experts and so on. So we are pushing for that. So it's not only our aspect, or in our lab also, we welcome scientists to learn how to do it. And so this is really important, as you know, to make this science out of our laboratory. So we develop the technology and push the technology to the forefront, and then we transfer as much as possible. And sometimes also we collaborate with some member states that are already in advanced level for this science to benefit other member states. So this is really important for us in Monaco to really push for this transfer of know-how, and the fact that the techniques are not only in our labs but also in the labs of the member states.
Excellent. Thank you so much, Mark, for being with us here on this event here about ocean change, climate change at the COP26. Now let me turn to our second speaker, and I would like to welcome Ms. Ashley Bantelman, who is a project officer at the IAEA's Ocean Acidification International Coordination Center. So Ashley, welcome to the event. Thank you very much for being with us, for being available for this talk. Now, I would like to ask you the following question. We have heard just now from Mr. Metian about what ocean acidification is and how the IAEA is studying its impact. I'm also aware that the IAEA has something that is called the Ocean Acidification International Coordination Center. Could you please tell us more about the center? What is the role in this whole picture, in this context of our discussion, which is, and I repeat, the connection between ocean change and climate change?
Yes, thanks, Martin. Hi, everyone. Welcome. Thank you for being here with us. So, as you've heard from Mark, ocean acidification is a big issue. And when IAEA member states and the rest of the international community started to realize that this was an issue, the IAEA responded by launching the Ocean Acidification International Coordination Center back in 2012. So it's been around for almost a decade now. And the agency launched it in an effort to promote international collaboration on this topic of ocean acidification. So through the center, the OAICC as it's known, the IAEA is helping IAEA member states better understand the impacts of ocean acidification on the diverse marine ecosystems worldwide. And the center is working in three main areas: in science, capacity building, and communication, to spread awareness about these impacts on member states and potential livelihoods in the member states. So since its inception almost a decade ago, the OAICC has worked to build and implement a global project. So we're not just, we're located here in Monaco, but we're working with global partners all around the world on the issue of ocean acidification. And we're also working to promote the IAEA's mandate of applying novel nuclear and nuclear-derived techniques to address climate change impacts to the ocean. So over the past decade, we have helped to raise global awareness of the issue of ocean acidification. We've led experimental research efforts. We've engaged member states on every continent to become active in understanding the issue of ocean acidification. And we do this by conducting specialized training activities and other capacity building activities. So now, being around for almost a decade, we have become an essential player in the international leadership on ocean acidification.
Excellent. Ashley, the center has been around for almost a decade, as you said, and you are doing capacity building, you are doing training, you are engaging with countries and member states and with their scientists on this topic of ocean acidification. Would you say, is there anything tangible in terms of results that this work has generated? Is there anything that you have achieved that you are proud of? Is there anything that our member states, our countries, or representatives that are listening to us can go to and say, oh, here is a wonderful, outcome or product that is useful for them?
Yeah, thank you. So, just to give you kind of some numbers, this center, the OAICC, and our global partners have worked together on more than 850 capacity building opportunities. So it's a huge number, and this has involved more than 750 scientists from more than 100 IAEA member states. So that's in over the past decade. And so, just to give you a more kind of detailed example, our capacity building activities fall into 4 levels. There's the very basic, just sharing theory on what ocean acidification is. Then there's another level, level 2, which is basic, but it's basic applied training. So it's a little bit hands-on. And then there's level 3, which is a bit more advanced, and then level 4, which is like coordinated research projects. But to just give one example, we had a recent level 2 training course in Kenya. So it's a basic hands-on training. It was a regional training course, and it was organized to provide some information and train participants in how to design a basic ocean acidification experiment, taking into account local needs and local capacities, because in the laboratories in Kenya, they didn't have necessarily the most advanced setup like maybe what we have here in Monaco. So this worked really well, and best practices were developed from it, and it kind of showed that we can do good science even with a basic laboratory setup. And it was, like I said, it was very successful. The first data were collected, and they're already ready to be published into a scientific publication. So then, aside from capacity building, we also offer a number of different resources for scientists and for our member states. So one of those is the bibliographic database. This is an extremely useful tool for scientists and researchers. It's home to all scientific papers written on the topic of ocean acidification, and it's updated regularly by our team here in Monaco, and it currently has more than 9,000 references.
Yeah, thank you, Ashley. That sounds fantastic. My last question to you. This is an international center, and so you must have some international partners or collaborators. Which are the partners or donors or affiliated institutions that you are working with in the center?
Yeah, so as you've heard from Mark, ocean acidification is a global phenomenon. So it's not it's from the very start we have worked to build this international network, and the success of the project hinges on our strong collaboration with our partners. Some of them are the Intergovernmental Oceanographic Commission, IOC UNESCO. We work with the U.S. National Oceanic and Atmospheric Administration Ocean Acidification Program, the Ocean Foundation, the Ocean Acidification Alliance, or the OA Alliance, and then we work with countless regional and country-specific partnerships around the globe as well, and many other partners.
Very good. Thank you so much, Ashley, for being available for this talk. Thank you for the insights that you have provided, and for making this Center on Ocean Acidification visible in the international context beyond the nuclear community. And that is what our event here is all about. So thank you so much, and I will turn now to our next and last speaker. And I'm very delighted to have Professor Perret Masquet here with us. Perret, you are at the moment a research scientist at the Radioecological Laboratory of the IAEA in Monaco. And we are delighted that you are with us, and I would like to ask you a couple of questions. My first question, Perret, to you is the following. We have heard from the previous 2 speakers here in this part of our event that the oceans are taking up a large fraction of the atmospheric CO2. And during the last decade or so, we have increasingly heard the term blue carbon in relation to nature-based solutions to climate change. But can you, Perret, please explain to us what is behind this term blue carbon?
Yes, hello, Martin. Thanks for having me, and thanks for organizing this event. The blue carbon, well, we call it blue because it's the ocean, and we assume the ocean is blue. Blue carbon refers to this capacity of the ocean to accumulate, to sequester carbon from the atmosphere, right? So Mark talked about that before. CO2 in the atmosphere is in sort of equilibrium with the ocean. So eventually, some of this carbon is fixed by the phytoplankton or the species, plants that live in the ocean through photosynthesis, and then it can be sequestered. Now, blue carbon in general would refer to all of this happening in the ocean, including coastal and open ocean. So in the open ocean, we talk about the biological pump, which is the detritus, the particles sink, and so they export the carbon. So we sequester this carbon, and it cannot be going back as CO2 to the atmosphere. Now, in the coastal ocean, however, what we find is something very unique, which is what we call coastal vegetated ecosystems, that is mangrove, salt marshes, seagrasses, right? They occupy a tiny amount of area in the ocean, less than 1%, much less than 1%, but they have a great capacity for sequestering carbon. So this carbon that's accumulated in the plants because of photosynthesis, eventually it's accumulated in the sediments beneath. So this is something different to what happens in the forest and land, which the trees do the same, right? But they don't accumulate sediments, so the sediments don't grow. In the oceans, the sediments grow. They accumulate at different rates, depending on where we are, but they bury this carbon and they sequester it efficiently, very efficiently. So basically, we're talking that about 50% of the carbon sequestered by the ocean in the sediments happens in this little amount of a space.
So the carbon that is sequestered then cannot be or is not being released to the atmosphere, and that is obviously very important. But Pere, how does it work? For how long, for example, is the carbon stored in the ocean or sequestered by the ocean?
Well, this has two answers. If the system works well, if there is no problems, if there is no changes in the system, naturally or artificially, these sediments shall stay there for thousands of years or beyond. We've actually seen that. I mean, seagrass meadows, for instance, where they accumulate sediments for thousands of years that we've bathed with carbon-14, for instance. However, if we perturb these systems, if we, for instance, destroy a seagrass meadow, if we deforest a mangrove forest because we use the wood, then these sediments are subject to being resuspended, for instance. And when they are resuspended, the carbon, organic carbon, which is in these sediments locked because it's anoxic conditions, then it happens to become in contact with the oxygen. That may become then CO2 because it's respired by bacteria, for instance, and then this CO2 may be emitted back. So what the problem is that when we destroy these habitats, that can happen naturally as well. But basically what has happened during the last century or so, we've destroyed a large percentage of these habitats worldwide. What happens is that two problems. The first one, we lose this capacity. We're not sequestering carbon anymore. So the ocean is not helping us, let's say. But at the same time, we run the risk, and it's happening, that we're emitting CO2 back into the atmosphere, first to the ocean, then into the atmosphere. CO2, which was carbon that had been there for hundreds of thousands of years. So in one go, we are losing two things.
Right. Let's talk about coastal ecosystems. What do we know about the capacity of coastal ecosystems? And here I'm talking about, let's say, mangroves, to sequester carbon. Is this a new frontier in the research? Is this already established knowledge? And where are we on this question of the coastal ecosystems in terms of carbon sequestration?
Okay. So this subject started being seriously studied in terms of climate change about a decade ago. That's when they coined this term, blue carbon. What we know is they are very efficient. What we know, there are differences depending on where we are in the planet. Mangroves in arid areas are not the same as mangroves in tropical sites, for instance, or there are very different seagrasses species. It depends on the physiography of the sites, etc. So that capacity for sequestering carbon varies widely depending on where you are in the planet. Questions, there are two main aspects here. The first one is that a large area of the planet has not been studied. I'm going to just give an example. Brazil holds about 10% of the mangroves worldwide, and there is a handful of studies about this carbon sequestration capacity in Brazil. That's, of course, very little, because we're talking that at the very least, the carbon sequestered in Brazil by mangroves would be about 10% of what's going on worldwide. So that's a limitation. Now, what I explained about how the particles sink and accumulated in the bottom sediments, it's the basics, it's how it works, but it's simple. There are more processes there. There's an aquatic environment, so this carbon eventually in the sediments can be respired by bacteria, can be transformed. There are different types of carbon in the system, more or less labile. So we need to focus more efforts on what's going on. And there is then a third aspect. We talk about restoration of all these ecosystems, so that for a number of reasons, and not only for the carbon sequestration capacity, because of course these ecosystems are important for a wide number of aspects in terms of their, what some call ecosystem services, right? But when we want to restore them, we need to assess what is actually the deal. We just published, for instance, a paper showing how different is the response in terms of carbon sequestration when we restore a salt marsh in a tidal or non-tidal environment. Let's say, that's it to say whether the salt marsh is going to be always or more or less submerged in water, because there's going to be growing plants, there's going to be a number of biogeochemical processes in there, and you can have at the same time that you sequester carbon, you can have emissions of methane, for instance, okay? And methane also is a greenhouse house. That needs to be studied. It's not as simple as it may seem. However, all the indications show that the potential role in mitigating climate change with restoration, compared with other natural solutions like forests on land, at the very least of the same order of magnitude, if not higher, particularly for mangroves.
So, Perry, in terms of your work with the IAEA and the labs in Monaco, they're using nuclear techniques or nuclear-derived techniques, isotope techniques. So what is happening in terms of the IAEA's involvement in this particular area of work that you are describing? What is the IAEA doing? What are the labs in Monaco doing? What are you doing on this?
That's a question I've heard a number of times. So why the IAEA would care about this? I mean, what's the deal with nuclear techniques? There is several aspects here, but the main ones are two. First of all, carbon has several isotopes, and stable isotopes have carbon-12 and carbon-13. I'm not going to go too technical in here, but depending on how much of each of the isotope we have, we can then understand what's the procedence of this carbon. It comes from this kind of plant, it comes from the other one, it comes from the terrestrial environment, etc. And we need that to understand what is the capacity of these ecosystems to sequester carbon. It's not the same if they sequester the carbon that's produced, that's fixed by the plants in situ, or it's actually accumulating the carbon coming from the land. The other thing is what I referred to before, which is we need to know not only how much carbon we find in the systems, in the sediments, buried in there for years, hundreds of years or thousands of years, but we also need to know at which rate. In other words, if we say, oh, it accumulates this much, a number, 100, whatever 100 is, in 1 year, it's not the same as it accumulates it in 100 years. So we need to date this system. So we take the sediment course, and we use techniques which many of whoever is attending this know about carbon-14. We use other techniques, and we establish the rate at which carbon is sequestered, at which the carbon is accumulated in the sediment. So we know the actual efficiency of the systems in sequestering carbon. And of course, then, this is what we do in Monaco Labs, but then as Mark explained before nicely, what we do is a lot of technical cooperation and research projects worldwide. So we assist and we collaborate with dozens, literally dozens of countries in doing this in any part of the world.
Pere, thank you so much for explaining to us the blue carbon and how the IAEA is also involved in this. I'm afraid that we come to the end of the part 2 of our event. We come to the end of our event. We are running out of time. But I would like to thank you and your colleagues for making yourself available to shed light on this very important issue, which is the connection of climate change and ocean change. Let me, with these words, then summarize or thank everybody who has been with us here, summarizing in the sense that, you know, it is not well known across the world that nuclear technologies, nuclear techniques, nuclear science is relevant for climate adaptation and climate resilience. We believe that now, after this event, and we will distribute also all the information that was talked about and transmitted here today, we will distribute it through our various social media channels, that this information will help to make this work more visible and to also help our member states, the countries, to get access to these kind of technologies so that they can better adapt to the climatic changes that they are going to face. I would like to thank everybody for being here, for staying with us. I know it's a Saturday afternoon going into the evening, so it is not so easy to be motivated and to be here, but I would like to thank everybody, and with that we conclude our event. We have, for those who are here physically, we have some, I'm afraid it's not beer or wine, I'm afraid it's coffee and tea and cookies and so on, but we have something here behind where you can go and we do some networking and a further exchange of views. Thank you very much and goodbye. Have a nice weekend.